Good morning, everyone. My name is Joban, and I'll be the stage host for Stage 1 today. I'd like to acknowledge the Gadigal people of the Eora Nation, on whose land ICC Sydney stands on today, on which we meet, and pay our respects to the elders, past and present. So, some housekeeping to kick things off. Please ensure all your devices are silenced as a courtesy to your fellow audience members. All sessions are being live streamed as well as being recorded and will be available after the event today. And please download the events app to give feedback after the session as well as to view all agenda items for today. Our first session for today is Palo Alto Networks, and we'll be hearing about how to secure AI by design. I'd like to invite to the stage Riccardo from Palo Alto Networks.
Well, good morning, everyone. Thank you for joining us today. It's always fun to talk to myself, but knowing that you're hearing me as well. So thank you for coming to AWS Summit and filling up the room. This apparently is the biggest stage, so I'm very pleased to see you all taking a seat. My name is Riccardo Galbiat. I'm the regional CSO at Palo Alto Networks. And today I will be joined on stage also by my colleague, Marc Gollop, later on through the presentation. Now, let's clear the elephant in the room first of all. You see AI in the title and you're going to be like, oh gosh, another one of those AI presentations. But let's be clear, we are not here to tell you about how powerful, how useful and how much disruption AI will bring to you and to your organizations and your customers. We're here to tell you how to adopt it securely, how to learn to trust it as well, and how to deploy it in AWS safely. So that's all about securing AI by design. Now, when we talk about AI adoption in general, at Palo Alto Networks we have identified two main trends that are not exclusive of each other. And in some cases they represent some sort of a spectrum, right? So there are those organizations that are trying to mostly consume third-party artificial intelligence, commercially available capabilities, and in most cases they have their own employees and staff using it even without their knowledge. And then there's the other world where you're actually building AI applications yourself. You are deploying them in cloud, in AWS, of course, using Bedrock as part of your foundational deployment. And those use cases are focusing more on providing value to your organization, your staff, your customers, and so on, using your own internal data. As I said, those two worlds are not mutually exclusive from each other, and the majority of the talk in this presentation will focus on the second group. Exactly, how to build secure AI applications in AWS. But we can't completely discount the first one, so let me touch on that first. Whether you like it or not, everyone has jumped on the AI bandwagon, so for sure someone in your organization is using these tools from their managed devices, from their personal devices, and one typical scenario is the one, we're having a meeting, a nice Zoom, virtual meeting, and someone in that group of stakeholders is tasked to take notes, right? And they need to write minutes and summary and actions, and there's a high chance that they're going to use an AI application to do the transcripting, taking notes for them, and then summarizing the whole outcome. By the way, this is a great use case for AI. That's one of the best potential uses of artificial intelligence. But then you start asking yourself, is that application accepted within the company? Where is the transcript actually going to be stored once it's recorded? Who will have access to it? And in the event of a breach of that company that is storing my data, who's responsible for it? Now imagine this multiplied by 2,500 applications that could perform this task, and you quickly start losing control of any sensitive information that could be contained into those conversations and others where AI is involved. The lack of IT visibility, the problem of shadow AI is real. We can't discount it. And so we have thought about a good way of protecting you against these use cases. The three-step approach that we are envisioning is, first of all, we want to be sure to understand all the AI applications used within your organization, the sanctioned ones, the unsanctioned one, the one that your employees are using and trialing at the same time, and understand the risk associated with these applications. Are they known to be containing potential vulnerabilities? Are they known to be susceptible to breaches. Once we identify and classify and even coach, in some cases, your users to use the one that you would like them to go for, we need to understand the data consideration. What data is transmitted up and what data is received back from these applications. We don't want sensitive information to go up, and especially we don't want malicious responses to come back. Think about code developers. If you get a code snippet back that contains vulnerable code and we trust it as it is, then it's going to end up in your production environments. So this three-step approach requires obviously network visibility. And at Palo Alto Networks, we have built a network security platform. You can see it at the bottom in this slide. And regardless of where this traffic is transiting through your physical network, through your virtual network, or even through a SASE service, we can implement this capability seamlessly in all these places simultaneously. That's the power of the network security platform. But enough said about consuming AI application, let's talk about building them. And if you are in this camp, you're not alone. Almost 50% of organizations today are building AI applications for the purposes of enhancing business and efficiency. And the availability of this in-house built application is going to skyrocket in the next few years. We estimate about 100,000 applications will be available by the end of next year. And Hugging Face, which, as you know, hosts all these models, is now ranking up almost 2 million models for you to choose and fine-tune and build your apps with. But things are not that simple, right? If we think about building an AI application, we have some similarities to how cloud applications have been built over the years, but there's an additional layer of complexity. We still go through all the problems of building a typical cloud app, and then we have to top that with training data, inference data, retrieval augmentation data, plugins, models, connectivity and APIs, and even optimization for GPUs. All these additional components bring complexity, and with that complexity, the attack surface increases. There are now hundreds of new ways to try and compromise AI applications that don't target the actual infrastructure, but target the AI components of the application itself. Think about prompt injection or deserialization attacks, etc. So how do we go about securing these new type of cloud applications that are AI applications? Well, we need to think about a framework. Because when I talk to most leaders that are pioneering the world of building AI applications, they're telling me, I actually don't know exactly what my developers are putting out there. I don't have full visibility of what models they're choosing or how they're combining them, what access they're giving. So this framework has to start with scanning. We need to be able to scan once you're starting to build in cloud, in AWS, scan your environment for all the connection and components that compose this AI application in the first place, and especially the models that are used. In cloud security, we tend to scan for code and infrastructure to make sure that there are no vulnerabilities. With AI applications, we need to scan the models themselves before they're making their way into production. The second step is posture. Posture assessment, not just of the cloud infrastructure, but also of the configurations of these models. Do they have configuration that allow them to be too permissive, or that give access to data and resources that they shouldn't in the first place? And all this should be done before the application is pushed towards production. And in fact, the third step before any application makes it to production tends to be red teaming, right? You want to test the applications against typical patterns of attacks and vulnerabilities, but with AI applications, we can't really rely on humans performing these tasks anymore. We don't believe that an AI application, which is by nature adaptive in its response, should be tested on a snapshot of time by a human. So AI-led red teaming should be the right way to test for an application vulnerability. These three steps are all conducted at what we would call peacetime, so before the application is actually put into production and running, so they're all related to posture and assessment, but then the app will make it to production, will be hosted in cloud, will be accessible to users and staff alike, and that's where runtime security has to come into play. Okay, we have checked it, it's safe enough for us to put into production. What happens when it's up and running? What are users actually trying to do with it? Are they trying to go around the boundaries or the limitations of these applications? We need to be able to intercept that and see that in real time. And the last piece is probably the biggest talk of the year. I was at RSA this year, and everyone was talking about agentic AI. By the way, anyone been on a Waymo in San Francisco? To me, that is the prime example of an agent with AI background operating in the real world, making real life-death decisions in the middle of traffic. But if we start applying the concept to any other realm where we're going to let an agent do tasks for us, have agency effectively, we need to be really careful on what we let this agent do. Now, with that being said, this is a decent starting point for a framework, and as you can imagine, the industry of cybersecurity has not been sitting idle on this and has come up with, I would say, a barrage or a patchwork of products. Each one of them addresses these issues individually, focusing on posture, focusing on runtime, focusing on red teaming, and we have been through this many times. At Palo Alto Networks as well, we have gone through cycles of optimization and consolidation into platforms, and so we decided that the best way to approach it is to do all this through a single unified platform that we have launched recently. It's called Prisma AIRS, which sounds cool, but it actually refers to AI runtime security. And as you can see, it tackles those 5 points that I just described, but it does it into 3 simple steps. Discovery, assessment of what has been discovered, and finally, protection. We need to know what we have, we need to know how vulnerable or exposed we are, and if we are, we need to protect in real time. I'll go through each one of these in the next couple of minutes. As we said at the beginning, scanning and discovery of models is fundamental. We need to have visibility of what the models are talking to, what data they have access, how are they trained, how they're interconnected with each other, how are they exposed to the internet or through plugins or APIs, which users have access to the models and interactions. All this is fundamental to map out your AI baseline starting point. And this is one of the places where most organizations have no idea. Once we do that, we need to start with assessment. This is where we want to verify, as we said, configurations, access to data, and actually potential vulnerabilities embedded in the models themselves. This requires the scanning of the model, but also verification against third-party testing. As you know, most reputable models are actually tested against these capabilities, so we can kind of have an idea already of the potential vulnerabilities they might contain. Beyond that, we need to elevate the layer, right? If the models are the reasoning layer, then we have the application layer, that is the more classic one, and we need to make sure that that is not also a vehicle to conduct an attack through and reaching the model. So this is all about verifying the posture of the application itself, how well it is configured, what type of access it grants towards the model, and beyond that. And finally, we get to that red teaming component. As I said, AI red teaming is the future. The way we have implemented it is effectively we created an AI agent that is designed to jailbreak AI LLMs. And we want to throw it and unleash it effectively against our AI applications to make sure that there is no safe spot to hide within those vulnerabilities. And the approach is quite interesting because it's not something a human could do on a continuous base. You can see that we simulate the AI attack with this agent targeting the LLMs, and we expect the model to react and to adapt to how we are attacking it. And so we need to refine the model itself, the agent, the AI red team agent, adapts itself in its strategies and constantly reports you on the findings and then starts the process again. This can be deployed continuously and maintain security against the posture of your applications as they are developed. So we went through discovery, assessment, now it's time to protect. We verified all we could do before the application was put into production, now we need to protect it while it's running. And this part focuses for the vast majority on data protection. As we know, sometimes we can trick models and AIs and LLMs to give us more information than they should, accessing sensitive information. If that was even possible, we can intercept it in line. And by matching against well-known patterns, also for unstructured data, by the way, because the typical language models is not a dump of a database component, but it's actually a request in human language. We need to detect those information within that human language coming from the databases where they were originally stored and stop them before they are made available to the public. Protecting AI applications also means, of course, focusing on those potential new methods of attacks against web-exposed, cloud-hosted applications that could be leveraged once more by a very motivated attacker to go through the boundaries of the application and come back through the model and accessing that data and information. So the last step is not forgetting about the foundational attacks that are conducted through cloud applications in general when related to AI models that are hiding in the background. And the last component, as we said, the protection has to also include the world of agents, which is going to be very familiar and very popular in the next few months. We believe that agents should be given agency, but they should be controlled with guardrails to make sure that they stick to the tasks that they were designed to do. If we have an agent that can send email for us or create calendars, we don't want it to start deleting files, or we don't want it to start exporting data from one database to another one, because agents will have the capability of performing those actions. We just need to guardrail their behaviors and monitor them at all times. So have you heard how we have decided to go about building along that framework? And the good news is, when it comes to deploying these capabilities, we'd like to give you options. So there are two ways that you can actually adopt this Prisma AIR's security platform. One is at the network level by dynamically inserting effectively a next generation firewall, which Palo Alto Networks is very famous for, inline into your AI cloud hosted environment to detect all these flows, to map your environment and provide that assessment and protection. Or you could choose a more developer friendly approach, if you will, which is AI security as code effectively by using an API insertion mechanism. So that can be achieved without any deployment itself, but in a few minutes embedded as part of the build phase of your application. In fact, you don't have to pick one, you can actually adopt them simultaneously. And the good news is that same platform that I described initially to protect you from consuming third-party applications, remember the world about consuming application, is the same platform where this Prisma AIRS is hosted as well. So imagine being able to manage both those scenarios and use cases through the same interface and console, not having, again, to use different tools for different means. But I think the best way to put this all together is actually to see a demo of it. So it is my great pleasure to invite on stage my colleague, Marc Gollop, who is a senior domain consultant for Australia and New Zealand, who will run you through a few scenarios of Prisma AIRS. Thank you very much in the meantime. Marc?
Thank you. Thank you very much. So yeah, let's move over to a demo. So what you'll see here is I'm going to take you on that, the wartime component in terms of the security. We saw that picture in the discovery, and what we're actually able to do is you'll see there that it looks at it discovers, you can actually go and connect it to your AWS environment, and it will go and discover all the different components of the models, the users that are actually communicating. On the right, it will give you reporting of what's going on, what's going through that system, what threats you're actually having. And you can actually take a security view where you can see it more from a security. The first one was more application orientated. So you get that security of what is happening. If we actually click into the models, we can see we've got a security view there. We've got our apps that we've built in AWS, and we're securing all the communication going to those large language models. So what you now get is, that's using the networking step. But as we mentioned, people often want to do it through API. What we have is two ways in terms of the API. We actually have a Python package that you can just inject into your application. See, it's pretty simple. You just give it an API key, you give it the profile, which is the configuration, and then you send your prompt and your response to the system. And what it's actually going to pick up is a number of things. The first thing is prompt injections. So it actually can look at different types of prompt injections. We have 25 prompt injection models that we look for, which puts our efficacy rate very high in terms of being able to look at. Same thing with malicious URLs. We're very good at looking at malicious URLs as well as malicious as well as categories that you may not want it to do. So we're able to actually define what we're able to do on that. We can then also go mask out sensitive data. And the sensitive data, we have, for example, a customer where what they've done is they've loaded up their chemical formula, because they're a cosmetics company, and they can actually identify that. So it's not just PI data, it's more than just that. you can mask out some of that data. So we can actually look at that, send the rest of the information, but just mask out that sensitive data. Toxic content we talked about, malicious code, same thing, picking that up, all within that one call. AI agents is the new area also. We actually pick up if there's memory poisoning. There's new attack vectors that people will come in wanting to actually connect to that and breach your system at the end of the day. Contextual grounding, this is hallucination. We want to make sure it stays on topic at the end of the day, as well as looking at your custom topic guardrails. Not just keywords, but we actually give an example where you put in examples of what good looks like and examples of what bad looks like, and the model picks it up. And finally, MCP. If you've all played in the AI space, you'll know this is the latest, greatest way of checking it. But you're getting servers that are giving you services, and you don't know if they are doing what they're doing, meant to be doing. Are they injecting malicious code? Or is their input and output checked? With this, you're actually able to look at that and do the discovery and block it as you connect to our services. So let's look at the service. Here's a Streamlit application I've got, and you can see I can actually run tests against all these components. But to keep it quite simple, what I'll do is I'll turn it on and I'll actually go in and look at a prompt injection. Now we've got a number of prompt injections that we do, and we do testing against a very large set, get very good efficacy rates of the 90-odd%. But this is one of my favorite. It's called fuzzing. So what you'll see is it's mixing up a sentence, and it doesn't make sense. When you look at it, it doesn't really make sense. But when I actually go and I connect to the system, what I'm able to do is you'll see the bot came back and said, yo, you were actually asking me about napalm. Probably not what you wanted to be checking, but it could be napalm, but it could be something else. And you notice there that we were actually able to identify it. I haven't put the blocking on, so it actually went through to the system. But you can see there, and there's the response I get back. It said it's picked up that it's malicious, and you can see that it's actually identified that it's a potential agent attack as well as a prompt injection attack at the same time. But we want to see this in AWS. So let's go look at a Bedrock agent. So I've created this little Bedrock agent. It just goes and looks at user details, and it's a bit of a leave app as well. Pretty simple to set up. And what I've done is I've put in two action groups. One is to check answers and questions, and the other one is the actual agent functions that I'm doing. And we can go in and actually test it real time there. So what I go in is I ask the information. I ask, what's the details in the Arora, our CEO? And you'll see it will go in and do these steps. And you can see this is real time as it's going through the system. And there we get his details, his LinkedIn profile, all that details. So what actually happened? It started with the first step. We had told the agent to call us. So there you can see it's making the Lambda call to check the actual question, make sure it's valid. Second step is it will move on to the next one, but in that we can actually see the response. So we can pick up here that there was the function call, and the same question came back with the answer, which says it's valid. We haven't changed the actual outcome of it. It would then go look up, use employee ID, look up the employee details, and then the final step is it calling us again to actually go and check, is this response valid? Should I actually allow it to go out? And there you can see the same thing. The function call occurs, comes in, picks it up, and it's responding with the same outcome again. So you're now actually able to go in and say, yeah, this is valid. But let's say, for example, now we've got somebody else who comes in, they had a homepage link, but in the meantime, it's changed. This was actually a link in this person, and they got a link there that up to a week ago was valid, and it changed real time. And this is something we're really good at, picking up that data. So what you can see there is it came back and it said, hang on, this contains a malicious link. And there you'll see in the user's data, when you actually go look at it, you'll see there's this URL. Now that can be a category as well, so it doesn't have to be malicious. You could go swimwear, for example, or something like that. Don't allow that. So you actually get that control without you as a developer getting involved in the actual process of writing that policy and implementing that policy. But let's go look at another one where we actually go look at user data. So we'll go and look at our CEO of LATAM, Helmut, and we call up his information. And we'll pick up there that Helmut's it's collecting all the information, comes through the process, and it will respond there, and you'll see a lot of details, but take note of that contract note, and you'll see an 8-digit number. Those of you who know, 8-digit numbers are regex matches for Australian driver's licenses. So now we go look at another user, and we go look at Karim. And goes in, collecting that same information, and that came back and said, hang on, that's sensitive data. And when we go look at that data set, you'll see, we'll actually see that there's an Australian driver's license in that. So scrolling down a bit, and there you can see the actual Australian driver's license. Now those who are keen eyes would pick up that it's the same number as the contract number earlier. And what I learned, the LinkedIn, also the number on the end of Nikesh's LinkedIn was also an 8-digit number. So it's contextual. It's not just a regex, it's actually giving you contextual information. And yeah, I'm onto the CloudWatch, and you can see the API call, exactly what I showed you earlier with the DLP triggering. Now, in terms of the management framework, what you can do is, on the management side, this is where you see the outcome. There you get in the logs, all the details of what's being pushed through, and you can actually see the config that I'm able to configure. So I get this config, multiple versions, and I go in and I configure it. Very easy checkbox, click, yes, what I want, what I don't want, all these different stuff. Toxic content, you can tell the level you want it at, guardrails, and there you get into actually seeing the malicious URLs. You can see I've defined swimwear as something that's malicious, which I want to block. So it's not just bad malicious, it could be non-topics that you don't want. So there's also my DLP, and you can see I'm looking at the Australian driver's license. Database stuff, AI protection, and probably the bit that developers like the most. You can define after a period of time if it fails open or if it fails closed. So your system and your user service won't actually suffer. Here I'm actually showing how simple it was to do the DLP. I just pulled in driver's license, put it in there. I'd probably have a lot more elements, but this kind of gives you the view of what it is. For the grounding, here's an example. I talked about contextual grounding. Here's an example. I just give a couple of examples. I don't have to think of exact words to match. I give examples and the AI model will actually pick it up. So as you can see, it gives you a very robust cybersecurity system. Our efficacy rate's very high. This is our core business, what we care about. And so we go plug this in, use it, and feel confident in taking your AI apps out to the business. Thank you very much.
Well, thank you very much, Marc. Well done. As you can see, there is a good way to secure AI applications while you're building them, and even if you are consuming them. And if you can do all that through the same security platform, then it's a bonus in itself. So please come and see us at the booth later on. We have further demos and we can go into a lot more detail with you. Thank you for coming once more. I'll see you soon.